Now we take up another problem, and this problem was asked in IIT JEE 96. The relevant ray diagram is shown on the screen. Now we have a slightly complicated optical system. Now here optical system consists of a lens which is sealed into the opening of a tank, and this lens has refractive index 3/2 and its focal length in air is 30 centimeter. And then we have a tank filled with water whose refractive index is 4/3 and the width of the tank is 40 centimeter, and the other side of tank is silvered. So we have a mirror as well as lens part of system. There is a point object which is placed in front of this optical system at a distance of 0.9 meter, that is 90 centimeter, and we have to find out the final position of image relative to lens. Now let's analyze this problem. Though it appears bit lengthy, but when we'll enter into calculation, you will find that calculations involved are very simple. First thing that we have to notice that mirror is a part of system. Now whenever mirror is a part of system, we have already learned in theory lessons that observer will be in front of a system. So object is in front of lens. So if we go event by event and we see that there are many events involved. First, it will be refraction through lens, and their rays will travel through water, will hit the mirror, get reflected, and these reflected rays will travel through water again and finally getting refracted out through lens. Now here we notice one thing, that the medium on the both side of lens is different. So we cannot make use of lens equation. Lens equation is to be used only when we have same medium on both side of lens. Here one side is air and the other side is water. Also we are given that the lens is equiconvex, refractive index is 3/2 and its focal length in air is 30 centimeter. We have already analyzed for this specific case using lens maker's formula that focal length will be equal to r. That means the radius of curvature of surface will be also 30 centimeter. So let's take up the first event. Now for the first event, that is air glass refraction, using appropriate sign convention and using the equation that mu2 by v minus mu1 by u is equal to mu2 minus mu1 over r, let's make the relevant substitution. Here the value of u will be minus 90 centimeter. Glass will be the second medium and air will be the first medium, and radius of curvature will be plus 30. Now one thing interesting, that we are not going to work out this equation completely, because for the next interface, which is glass water interface, this image formed will be acting as an object for the next interface. Now the lens is thin, sign convention remains the same, so this V1 will be as it is with sign u for the next interface. Now we write equation for the next refraction. Now for the next refraction, mu2 will be 4/3, mu1 will be 3/2, u will be v1 as it is. So when we make this substitution, we get the equation that is 4/3 over v2 minus 3/2 over v1 is equal to 4/3 minus 3/2 divided by minus 30. Now when we add these two equations, we see that v1 is eliminated. That's the point for not calculating these equations completely. So when we add these two equations, we get the value of v2, that is image distance after two events, that is air glass refraction and glass water refraction. So we get the value of v2 as 120 centimeter. That means image is formed in the direction of incident rays at a distance of 120 centimeter. Now, before these rays converge, these rays are intercepted by mirror. Now it's a plane mirror. Now this image, which is at a distance of 120 cm in the direction of incident rays from lens, will act as an object for the plane mirror. Now, noting the width of the water tank, we find that this image, which is acting as an object for plane mirror, is at a distance of 40 cm behind the mirror. So from the property of image formation by plane mirror, we will have image formed at a distance of 40 cm in front of mirror. Now, after reflection, these rays are travelling back. Now this image, that is 40 cm in front of plane mirror, will act as an object, and again we'll be writing the two refraction equation, that is one for water glass interface and then next for glass air interface. And again reminding ourselves that we'll not be solving these equations individually, we'll write these two equations and we'll add. So take care of sign convention, because now the direction of incident ray is changed. So leftward will be taken as positive and rightward will be negative. So putting appropriate values and taking care of a sign convention, we write the two equations which are displayed on the screen, and when we add these two equations, we get the position of final image. Now the position of final image, that is V3, we are denoting it over here, it is minus 90 cm. Now minus 90 cm means the image is formed towards right at a distance of 90 cm of lens. Hence we conclude the final image relative to lens is formed at a distance of 90 cm towards right.